Hello guys, so for today's video, we'll be talking about the chapter 8, Subnetting IP Networks Summary. So before we start, I am Mark James Frago from BSIT 2107 from Batangas State University, Alangilan Campus. And now guys, let's start. Subnetting an IPv4 network. So we have broadcast domains. Each router's interface connects a broadcast domain, and broadcasts are only propagated within its specific broadcast domain. So this is the topology, or this is uh, the representation of these broadcast domains. So this is the R1. This is the internet, and this is the broadcast domain. So the problems with large broadcast domains is that slow network operations due to the significant amount of broadcast traffic. So slow device operations because a device must accept and process each broadcast packet. So reasons for subnetting. Why we need to subnetting an internet or network. So network administrators can group devices in each and services into subnets that are determined by location. So reasons of subnetting. So network administrator can group devices and services into subnets that are determined by organizational unit. So reasons of subnetting: network administrators can group devices in each and services to subnets that are determined by device type. So subnetting an IPv4 network. So we have octet boundaries. Subnetting network on the octet boundary. Classes subnetting. So this is the classes subnetting example. So we have creating two subnets. Over 25 subnetting topology. So this is the topology. Subnetting formulas. To calculate the numbers of subnets 192.168.1.0. So 2 raised to n is equal to bits borrowed. Creating 4 subnets over 26. Subnet topology. Subnetting A over 16 and A over 8 prefix. So this guys is the representation, or the for you to understand, creating 100 subnets within a over 16 networks. 172.16.0.0. Subnetting to meet requirements. Subnetting based on host requirements. Two considerations when planning subnets. So we have the number of hosts, address required for each network. So the number if individual subnets needed. So it's very needed. And subnetting based on network requirements. So we have the research and development, technical support, sales, engineer, human resources, and executive management. This is the what we call the corporate network. Network requirement example. So we have corporate network, we have LAN 1, and that's for engineering. 30 hosts. LAN 2 is for human resources. We have 23 hosts. LAN 3 sales is for sales, mga sales, 40 hosts. And we have LAN 4 for the technical support, 35 hosts. And LAN 5 for exec management, we have 10 hosts. So the network requirements, examples, we have the 4 bits borrowed from the host portion to create subnets. Benefits of variable length subnetting masking. Traditional subnetting wastes addresses. So this is the topology, guys. Building A, 25 hosts. Building B, 20 hosts. Building C, 15 hosts. Building D, 28 hosts. So for subnet portion, we have 2 raised to 6 is equal to 8 subnets. For host portion, we have 2 raised to 5 minus 2 is equals to 30 hosts per subnet. So variable length subnet masks. Subnet mask, one of subnet was further divided into to create 8 smaller subnets of 4 hosts each. And VLSM chart. Section 8.2 Addressing Schemes. Upon completion of this section, you should be able to implement a VLSM addressing scheme. Structured design. Network address planning. Planning IP address assignment. We have the student LAN, faculty LAN, admin LAN. Planning requirements decision on each subnets in terms of size, the number of the hosts per subnet, and how host addresses will be assigned. So, planning to address to the network, primary considerations when planning address allocations. We have planning address allocation, prevent duplication of addresses, provide and control access, monitor and security performance. Assigning addresses to devices. So the summary of this chapter 8 is that implement an IPv4 addressing scheme to enable end-to-end connectivity in a small to medium-sized business network. Given a set of requirements, implement a VLSM addressing scheme to provide connectivity to end users and a small to medium-sized networks. So, explain design consideration for implementing IPv6 in a business network. So, that's all for this summary of our chapter 8. Again, which entitled the subnetting IP networks. So I hope, guys, that you learned a lot for this summary, chapter 8, subnetting IP networks of CCNA 1. And again, guys, my name is Margin Frago, and I am from Batangas State University of BSIT 210 section 2107. And I hope, guys, to see you soon again on my next video, which is our chapter 9. of our summary in this CCNA 1. So, that's all for today, guys. And thank you and mabuhay. God bless.